Right, let's carry on with circles then. So we're now going to introduce some circle theorems. We're also going to introduce some coordinate geometry from earlier in the course, specifically to do with straight lines. And you can see here that there's three circle theorems that are relevant to us because they feature right angles in them. So we've obviously got a right angle in a semicircle, we've got a tangent and a radius meet to the right angle, and one that people tend not to really know from GCSE, the bisector of a chord is a diameter, and that perpendicular bisector to be precise. So a chord and a diameter will meet at right angles if it's the bisector. So let's see how we can use some of these. We've got a question here. A circle C has equation x minus 2 squared and y plus 2 squared, etc. So we're going to find the equation of the tangent to the circle at 10, 0. So, something I would recommend with these slightly more in-depth circle questions is that you sketch it out. Okay? We know that this is a circle. We know that the centre of the circle is 2, 6 from the first 2 points. So 2, 6. And we also know that the radius of the circle is 10. So if this is 2, 6, then the circle is going to extend down below the x-axis to, I think, 2 minus 4. And it's also going to extend across the y-axis to, what we call that, minus 8, 6. It's just worth thinking about, which axes is it going to cross, etc., etc. Okay, that's almost a good drawing of a circle. Let's see if we can do slightly better. No, that's horrendous. Oh well, we'll live with it. So what I need to do is I need to find the equation of the tangent to the circle at 10, 0. So that's going to be about this point here. And a tangent obviously meets it at a right angle. So I'm going to have something like that. That's my tangent. And that's going to meet the radius to the circle at a right angle. So how am I going to find the equation of that tangent? Well, if I want to find the equation of any line, I need to know a point on that line, and I need to know the gradient on that line. So I'm going to try and use this to find the equation of the tangent. But we don't know the gradient of that line. We do know that it goes through 10, 0, so that's our x1 and our y1 sorted. But we want to know the gradient of that tangent. And to do that, we're going to find the gradient of the radius, and then we're going to do negative reciprocal. So we're going to find the gradient of the radius, and that we can do because we've got 2 points on that radius, so it'll be 0 minus 6 for the y2 minus y1 and 10 minus 2, which gives you minus 6 over 8, which is minus 3/4, which looks about right because you can see that that line, that radius is going downwards, so we'd expect a negative gradient. And so we can use the negative reciprocal, so m is equal to 4/3. Flip it. And then we can use our equation. So we can go y minus, so our y1 is going to be 0, so y minus 0 equals m, which is 4/3, x minus 10. Now it doesn't say what form to put this in, so we could just leave it like that, but I'm just going to expand it so it's y equals, and that's it. That's the equation of our tangent to the circle at that point. Okie dokie, so slightly more difficult question. We've got here a circle with a centre and a diameter. Now I think what we're going to do first is work out the equation of that circle. We've got a line with a gradient of minus 3, which is a tangent to that circle, and we want to find the two possible equations for that tangent. Let's get the equation of the circle first. So it's got a centre 5 minus 3, so that would be x minus 5 squared, y plus 3 squared is equal to, well, the diameter is 2 root 10, so the radius is equal to root 10, so that's equal to 10. Now, we probably want to sketch this out again, because it would be useful to think about what we're up against here. We know the centre of the circle is at 5 minus 3, so that's roughly speaking around about there. We know that the radius is about 3 and a bit, maybe 3.1, 3.2. So that means that this circle will go slightly above the x-axis, won't touch the y-axis. So we can draw, roughly speaking, our circle. Then we want a tangent to that which has a gradient of -3. So -3 is that sort of direction. So think about where that would have to be if it's a tangent for the circle. Well, we could have one something like here, and we could have one something like there. I'm going to try and draw that so it actually touches the circle. Yeah, that'll do. So those are our two tangents. We know that the radius and the tangent meet each other at right angles, and we know that in fact the whole diameter does. So if we know that the gradient of the tangent is -3, then negative reciprocal, the gradient of the radius is 1/3. Okay, so now we have a lot of information about that radius, about that diameter, because the radius goes through the point 5 -3, and it's got a gradient of 1/3. So we'll find the equation of the, let's call it the diameter. This would be y plus 3 equals 1/3 x minus 5, because it's got the point obviously 5 -3, and it's got that gradient we just talked about. Okay, so is that any use to us? Maybe. What could we do with this? Well, we kind of need to know, if we want to find the equations of the tangents, we need to find the point that they intersect the circle. And what we found is we found the equation of this diameter. So we can find where does this diameter intersect the circle, and that should be the same point that the tangent hits the circle. So we're going to find the intersection of C and the diameter. That means we're essentially doing a little bit of a simultaneous equation. So we're going to substitute in our y plus 3 equals 1/3 x minus 5 into the equation up here. So let's do that. X minus 5 squared plus 1/3 x minus 5, and all of that is squared, equals 10, and that should let us find the x coordinates, and that should be fine. So how do we solve this? We probably need to expand. So we're going to have x squared minus 10x plus 25. We're going to have to square the third, so that'll be a ninth, and then we're going to have again x squared minus 10x plus 25, and then we still got equals 10 over here on the side. And I don't like this ninth, so I'm just going to times everything by 9 and go to 9x squared minus 90x plus 225 plus x squared minus 10x plus 25 is equal to 90. And then I'm going to combine everything together. So 10x squared minus 100x 250 plus 160 equals 0, and fortunately that can be divided by 10. So x squared minus 10x plus 16 equals 0. Okay, that's factorizable. Minus 2 and minus 8 would make that work. And so we can get from that that x equals 2 or x equals 8. Now we can then go back, sub it into the equation of the line to work out what the y coordinates are. That would be that y is equal to 1/3 of x minus 5 minus 3. So if we subbed 2 into there, we would get that y equals 1/3 of minus 3, so that's minus 1 minus 3, that's minus 4. And if we sub in 8, we're going to get 8 minus 5 is 3, 1/3 of that is 1, 1 minus 3 is minus 2. So what we've got are the two coordinates, which are 2 minus 4 and 8 minus 2, where the tangent meets, where the circle meets the diameter, and so also where the tangent meets the diameter. Now we haven't answered the question because it wants us to find the possible equations for L. So we found that our coordinates, we've got one over here, which is going to be our larger x value, is going to be 8 minus 2. And we've got 1 down here, which would be 2 minus 4. So now we can find the equation of our line. So we can find, let's change colour, we can find the equation of the tangents using the fact that they've got a gradient of minus 3 and they've got one of those coordinates. So let's find the one where x equals 8 first. Y plus 2 equals minus 3 brackets x minus 8. I don't think it gives us a specific form that we need, does it? Oh yeah, form y equals mx plus c. So we're going to need to expand that. Minus 3x plus 24 minus 2, so plus 22. Or we could use the 2 minus 4 point, so y plus 4 equals minus 3 lots of x minus 2. So y plus 4, so that would be minus 3x plus 6 minus 4, so plus 2 overall. So those are our two equations put in the form the question wants. Good question, that. And then there's one more to think about. So here we've got a midpoint of a line. We've got a line that goes through M and C, where C is the centre of our circle, and we don't really have much information about the circle itself. And you can see that part C is find the equation of the circle. So let's do this step by step. It says line L goes through M and C, so this is our line L. If we want to find the equation of a line, we need to know its gradient and we need to know its a point on it, and we don't know either of those things, so we're going to start by finding M. M is a midpoint of P and Q, so to find it you need to add the two coordinates together and halve it. So that's going to be so minus 7 plus 3 over 2 and minus 1 minus 5 over 2, which is going to be minus 2 minus 3. Fair enough. And we also need to find the gradient. And again, we don't know anything about the gradient of L, so we're going to find the gradient of PQ, and we're then going to do a negative reciprocal there. So that would be minus 5 plus 1 over 3 plus 7, minus 4 over 10, that would be minus 2/5. So that would give me that the gradient of L is equal to 5 over 2. So if I now want to find the equation of L, putting all that information together, I would use the coordinate M, and I'd use the gradient 5 over 2. So we could say y plus 3 is 5 over 2 x plus 2. It doesn't say that we need to do anything fancy with it, so I might just leave it like that. Maybe work it into y equals 5 over 2x, that would be 5 minus 3, so 5 over 2x plus 2. Okay, so what do we actually want to do with that? Well, we then need to say, well, if the coordinate, or if C, the centre of the circle, is x minus 8, we want to find what x is. So we've got to remember, obviously, that that's on the line that we've just drawn. So all we need to do is substitute in that y equals minus 8. That will give us minus 8 equals 5 over 2x plus 2. Minus 10 is 5 over 2x. And so divide across by 5 over 2, and it will tell you x is minus 4. Fair enough, that part of the question wasn't too bad. And then our part C is we want to find the circle equation. Okay. So how can we do that? We need to know the centre of the circle. And we found that because we did that in part B. So C, we can say that the centre is minus 4 minus 8. And we also need to find the radius of the circle. So the radius, if we were to draw it onto this diagram, will be the distance, for example, from C to Q. That would be our radius there. So we could use Pythagoras to do that because we know that a chord, if it's a bisector, which it is because it's a midpoint, meets at a right angle, so we can use Pythagoras with those two lines. In fact, I don't actually think we even need to do that, do we now? Because we can just go the distance from C to Q. So we're going to find the distance from C to Q. C is -4 minus 8, and Q is 3 minus 5. It is 3 minus 5, isn't it? Yep. So, we want to use some Pythagoras for that. It's the difference in x squared, so 3 plus 4 squared, and the difference in y squared, so -5 plus 8 squared. That's going to be square root of 7 squared, add 3 squared, which is the square root of 58. So that is our radius. Putting that all together, that'll give us our circle equation of being x plus 4 all squared plus y plus 8 all squared is equal to radius squared is equal to 58. Cheers.